Effusion. Effusion in simple terms is the ability of gas to travel through a small opening. Effusion occurs when the size or aperture of the hole is smaller than the mean free path of the molecules. Examples of effusion. A deflating balloon. A fully inflated balloon gets deflated over time, even after getting perfectly sealed or tied at its end. It's possible only because of the process of effusion that causes the balloon to get deflated. A vehicle's tire loses air and turns flat even when it has not been driven for a long time. It happens because of the phenomenon of effusion, as in a properly sealed tire, air pressure drops over time through effusion. Diffusion. Diffusion is one of the most random natural phenomena. Diffusion is defined as the random movement of particles from a region of higher concentration to a region of lower concentration. The rate of diffusion is inversely proportional to the concentration gradient. In general, we know that when a sample of gas is introduced to one part of a closed container, its molecules very quickly disperse throughout the container. This process by which molecules disperse in space in response to differences in concentration is called diffusion. The gaseous atoms or molecules are, of course, unaware of any concentration gradient. They simply move randomly. Regions of higher concentration have more particles than regions of lower concentrations, and so a net movement of species from high to low concentration areas takes place. In a closed environment, diffusion will ultimately result in equal concentrations of gas throughout. Examples. When perfume is released, it quickly changes into vapor. The kinetic energy of gas molecules is high, thus the vapor particle moves in all the direction and diffuse in the air. That is how the smell of the perfume reaches to us, and we can smell perfume meters away. When someone is cooking food in a kitchen, the smell begins to waft through the house, and eventually everyone can tell what's for dinner. This is due to the diffusion of odor molecules through the air.